What up, viewers? Welcome to the Daily Space Weather. We've got some solar imagery and more to show you today. So let's do it here at the Smash News Network, least busted. Name and news, here's 94 angstroms from the Solar Dynamics Observatory. Most activity occurring in the southern hemisphere. There's a coronal hole and a sunspot group down there. It's still beta class. It's the most likely spot to produce significant solar flares. It produced a C-class flare just a couple hours ago. And there is a close-up of that. This is the colorized magnetogram from the Solar Dynamics Observatory. That group in the north is looking like alpha class. It might even degrade further today. The radial flux has dropped. We'll get to that in a moment. Here's the northern hemisphere in 94 angstroms. That is still a sunspot up there, by the way, folks. And here's a full disk view in 171 angstroms. Radial flux all the way down to 83, so looks like solar activity diminishing once again here. Here's the one-year chart of the radial flux, which is this black line. The red line beneath it is the sunspot number. Those are the most proportional data sets we have to solar activity. Space weather enthusiast dashboard not showing any solar storms expected in the next 3 days. Let's look at global seismicity briefly. No major quakes over the past 24 hours. Let's check the list at USGS. Albania saw a 4.6. That's a pretty rare spot for a quake, folks. Also a 4.9 at Tonga. That's a pretty common spot for a quake. A couple of small quakes there in southern Alaska. It's been pretty calm over the past 24 hours. However, there is an earthquake drought occurring. It's been a long time since a 7 magnitude earthquake. Barely even seeing a 5 magnitude earthquake over the past 24 hours. It could be the calm before the storm, folks. Please have an earthquake plan. Look at that. That's an earthquake drought. That's a lot of space in between the red bars, which represent 7 magnitude earthquakes. There's what it looked like in 2018. A really long drought happened then. And at the end of that drought, guess what happened? A large earthquake in the 8 magnitude range. There's 2019. There's 2020. And there's 2021 year to date. There's the past 90 days. Volcanoes have calmed down a little bit as well, although La Palma is still producing an 8,000-foot plume of volcanic ash as it explodes on the Isle of La Palma. Subanosejima, flight level 070 from the Ryukyu Island volcano. Subanosejima. Sibisa-Pochnoi. No information provided on that. It could be erupting. Don't assume it's not. Fuego in Guatemala is certainly erupting. 16,000-foot ash plume there as it explodes. Nevado del Ruiz in Colombia, producing a 21,000-foot ash plume, flight level 210 as it explodes. Sangay, likewise, explosive activity there. It's producing a 19,000-foot plume of volcanic ash. Please don't fly your John Denver-style hang glider over the caldera. Volcanic ash not observed in satellite imagery for Revenador, though, so there is certainly a large ash plume there over Ecuador from Sangay. Sabancaya exploding, flight level 230. It's a 23,000-foot ash plume. Please do not pole vault the caldera. We need the views on YouTube. And for you to share the videos and press like and subscribe and so on, check out our links below the video. You'll find our red bubble shop there. That's why I keep saying do not pole vault the caldera. So check that out. Today's featured product is Mansa. Make America not suck again. It's up to you, not giant heaving bureaucracies that can't even get out of their own way. How are they going to get out of yours or tell you anything about anything that you ought to be doing? Whether it's health advice or economic advice or who knows? Make America not suck again. It's up to you, not bureaucracies. If you think that a bureaucracy is competent because it's large, I would beg to differ. I would tend to believe that the larger a bureaucracy is, the more likely it is to be incompetent. As I've worked for many large bureaucracies, and not one of them has been competent. That is a large insurance company, a large science company, a large financial services company, and more companies that can't get out of their own way. So welcome to the neo-renaissance. This kind of complete incompetence when it comes to organizations like Facebook are why we created our website in the first place. We were sick of getting censored, so we wanted our own server so we can put up whatever we want. Check out the links once again below the video. Support the channel. Welcome to the neo-renaissance. smAsho merch is the link that'll take you to these products. So check them out. They make great gifts for your friends and foes and science noobs and science pros. smAshomash.com. Welcome to the neo-renaissance. And Mansa, make America not suck again. Next, a deep dive in magnetic data. Here's the GOES magnetometers over the past 3 days. It's the GOES 16 and 17. Fairly smooth here. Earth is in a South Pole current sheet. There could be a North Pole current sheet coming. We'll be keeping an eye on that. And when I say eye on, pardon the pun. Here's the line of sight ecliptic plane field plot. Current sheet shown here from our perspective as opposed to above on this view. Also shows you the magnetogram. Again, most likely region to see a lot of activity would be from this sunspot in the southern hemisphere. Here's your coronal hole plot. And we'll show you some great close-ups of this now well-defined southern coronal hole, trailing the most significant sunspot, at least on the Earth-facing portion of the solar disk. There it is in 193 angstroms. What evil lurks in the heart of coronal holes? What evil lurks in the heart of YouTube producers who are lying to you about the sun, cosmology, and all kinds of other things? That won't happen on this channel. We appreciate things like integrity, skill, talent, and training. Here's your flare monitor and detected sunspot groups. Most likely place for additional flares is out of sunspot 2894. 2895 has been degrading steadily. It's looking like alpha class nowadays, which drops the likelihood of major flares. We could degrade to only one sunspot group today, which would be 2894, which is where the C-class flare came from. Peak flux of that was about 840. I'll say 845. Peak flux was around 840 there. It was a C-class flare, nothing to write home about. The proton flux, no changes in that over the past 3 days. Real-time solar wind looking a little uneventful here as well. There was a thing looking a little bit like a coronal mass ejection strike right about here. Very minor. You can see a change in the phi angle, the solar wind density, the solar wind speed, and a little bit of change in the plasma temperature there. A little tiny coronal mass ejection strike is what that looks like. Current conditions are solar wind speed quite low here, down to 328 kilometers per second. Not dense either. It's a bit diffuse at 4.78 protons per cubic centimeter for the density. BZ just dipped into negative territory. That's not going to do very much for anything. The KP index is only at 1. And for you new viewers, the KP index is a measurement of global geomagnetism. If you want to read more about it, go to the Planetary K index page, click on details, and it'll explain all about it. Next, magnetohydrodynamic pressure in the Earth's geospace, out to about a dozen Earth radii. It's 4 hours of space weather modeling framework Geospace magnetosphere movie. Most of the magnetohydrodynamic pressure here is likely on the magnetotail side, the portion of the planet not facing the sun, the opposite side of the planet. Pretty uneventful last 4 hours. Next, ground magnetic perturbations here, showing you changes to Earth's B field on the surface level, known as Geospace delta B. It's, again, 4 hours of data. There is a geomagnetic excursion going on. If you're frightened of it, leave us a comment and tell us why. It should include some sort of physics explanation as to why you'd be frightened of a geomagnetic excursion. I'm not scared in the slightest of it. But we're not discounting your feelings if you are frightened of a geomagnetic excursion. So it's the 13th. Did you know that yesterday was the 22-year anniversary of my getting hit by a truck? It's true, folks. It's true. Back in 1999, my life was changed when I was hit by a truck. Anyway, here's where stuff is located in the solar system. Maybe I'll have to make a video about getting hit by a truck. Let's advance this 1 week. And there is your 7-day solar system forecast. That'll be the day after a full moon, it looks like. And next we've put up a star chart here. Mars and Mercury rising ahead of the Sun. No surprise there. We've also drawn on the ecliptic, which is the yellow line, the galactic plane, which is the blue line. Also, stars and deep space objects. So if you use in-the-sky.org, if you draw in all those deep sky and planets and so on, you can actually get links to things like Galaxy NGC 2264. Just click on it. It'll pop up, and you can click on that little green box for more details. My star chart faces the south, as I'm currently facing the south. Let's take a look at our coronal mass ejection watch. We're going to look at L5 and L1, where stereo A and the LASCO C3 are located. Those are respectively on the left and right of your screen. Stereo A on the left, LASCO C3 coronagraph on the right. We are expecting additional coronal mass ejections. It's a coronal mass ejection watch. We've lowered our warning to a watch from yesterday. Don't be surprised to see that tick right back up again. Today's cosmology segment is going to be brief. Just taking a look at the hard X-rays here from Cygnus X-3. This is the star Deneb. And were you aware that that's the brightest intrinsic object visible from our solar system? Yeah. It's the brightest object, the brightest intrinsically bright object visible from the solar. Now, there are stars that are brighter, and it's because they're closer. Deneb is a very active star. The Wolf-Rayet star that the more massive object is orbiting is about the size of Mars's orbit, meaning if it were in our solar system centered where the sun is, you'd be inside of it. We may be coming out of a quiescent state here. We're seeing some little upticks here in the hard X-rays, making it up to 0.03 here, which would be about here on the graph. So perhaps returning to a more nominal level. We'll be very interested in seeing what Cygnus X-3 does next. It is the tail of the swan, Deneb. The ancients believed all life came from and returns to Deneb at the end of life. Göbekli Tepe is oriented toward it, and if you want to read more about Cygnus X-3, head to our forum at smashamash.com/forum in the Cosmology Forum. Check it out. We've got a comment on the astronomy picture of the day. Just great imagery there. Spectacular. So that's apod.nasa.gov's astronomy picture of the day. It's a comet with a Russian name that I'd prefer not to try to pronounce. And this reached its closest pass to the sun, I believe, on November 2nd. It was a little bit too faint to see with the naked eye. Its closest approach to Earth was just yesterday. It did get to about 0.42 astronomical units, an astronomical unit being the distance from Earth to Sun, about 93 million miles, rather. So it reached a distance of about 40 million miles there. That comet known as Churyumov-Gerasimenko. Churyumov-Gerasimenko. 67P, the astronomy picture of the day. Did you know there's an almost total lunar eclipse coming in only 6 days? We're not too concerned about it. We'll cover it when it gets a little bit closer. And check this one out. It's a supernova remnant, a massive nebular cloud around a star that got a little bit antsy as Hubble captures the unusual shredded remains of a massive cosmic explosion. Yeah, it's a SciTech Daily article. It's from yesterday. I'm going to let it scroll real quick. Feel free to pause the video, folks. That was sufficient. That's today's cosmology segment. It was integrated into the Daily Space Weather video. Check our playlists for more. YouTube.com/smashamash/playlists. No charging hazards at the moment for satellites. Here's the relativistic electron flux over the past year. Here it is over the past 3 days. That's the greater than or equal to 2 mega electron volt electron flux from the GOES 16 and 17, briefly making it into minor warning levels yesterday. Nothing likely to cause any significant communication errors or anything like that. Continuing on, there's a forecast model. And the forecast is for slightly lower levels, nearly flat levels there, no complaints from me. Next, a diagram of Earth's Van Allen belts showing you distances in miles. Here is the total electron content forecast, and we're seeing some chaotic, anomalous electron bands here over both the southern Indian Ocean and North America. I'll let it play through a second time. This is the view that's going to show you the most likely places for GPS errors. The total electron content shows you the entire air column up to about 13,000 miles of altitude down to your ground level, giving you insight into Earth's magnetic fields and the structure of the Van Allen belts at those times. Most GPS errors occur around the equator at noon. Here's another diagram. Distances are shown here in kilometers to show you where the F layer is at 300 kilometers of altitude. It's just one slice in vibrational frequency, and we're seeing certainly some anomalies there in the southern hemisphere. Places like south of Africa, the South Indian Ocean, South Atlantic Ocean, as well as some high-frequency anomalies in the South Pacific. And we'll show you the anomaly gram as well. So here is the anomaly map. This is anomaly in megahertz from the 30-day median. Lots of low-frequency anomalies here around the equator, just north of it. And then some big-time low-frequency anomalies north of the South Atlantic anomaly, which is now over the South American continent. It's someplace like here. And some high-frequency anomalies occurring here around northern Antarctica. Anyway, there's the latest image in your anomaly gram showing you low-frequency anomalies in red, high-frequency anomalies in blue. Some occurring right here in the northwestern Indian Ocean, west of India. There's the ionogram, and there's the anomaly gram. And here are your bonus features. Next thing we've got is the hydrogen alpha imagery from the El Teide, Spain ground-based solar observatory. You can see some filaments up here, some real obvious filaments. Coronal mass ejection watch still in effect. It could suddenly turn into a warning, and only the smAsho team will get those updates. Current state of affairs is coronal mass ejection watch, downgraded from yesterday's warning. There were some stealthy CMEs that we're not even going to cover in the video. Here's your latest intensity gram. And that sunspot has actually grown since we did show prep. This one, oh, there's a new sunspot as well. Check it out. New sunspot right there, folks. So that's something. Here's the colorized magnetogram. There's 2894. That's grown. So yeah, a bit of an uptick there in solar activity just while we did the show. Here's the NASA GOES 16 SUVI imagery. This is quite current. Check out the time and date stamps there down in the lower right. Could be a little CME popping off right up here as we make the video. Right there at the end, right there. Could be a CME. It looked like it probably left the corona. And we'll close out the video with this fantastic imagery here of the southern hemisphere. Sunspot 2894, the most likely spot still for major flares, as well as a view of that coronal hole. Thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of smAsho News Network, least busted. Name it news.